This video is for informational purposes only and is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician with any questions you may have regarding a medical condition.
The amount of total testosterone you have is necessary, and the amount of testosterone-bound SHBG is also very important. No more, I don't want to hear any more about free testosterone is the most important metric because the Endocrine Society said it.
Hey, what's up, YouTube? This is Eric at Hormones for Me YouTube channel with Ryan Root and Jay. Tonight we're going to get into an SHBG deep dive that Ryan has been working on for some time, and Jay has put together a great outline as well. So we're going to get started and pass this off to Ryan.
Thanks for being here, Eric, and thanks for being here, Jay. This should be the most comprehensive deep dive on SHBG that's out there on any educational platform. The only other one talking about this is Vigorous Steve, and I do reference him within this outline. We're going to look at some deep dives in the SHBG about how it facilitates the efficacy of the testosterone in your blood and how it's much more important than anyone realizes or understands. So let's get right into it. Okay, so in order to understand the problem with the current understanding is first we have to understand the current understanding or the contemporary understanding. So, the medical community has this facile understanding, and let's continue with an introduction to the free hormone hypothesis and the antiquated understanding of SHBG. The medical community's knowledge of SHBG is antiquated and facile. Doctors often are unaware of the deeper understanding of SHBG due to their oversimplified and incomplete model. The medical community espouses the free hormone hypothesis, which outlines a simplistic role for SHBG. They hypothesize there is a one-to-one binding stoichiometry, or one testosterone molecule binds to one SHBG protein and is subsequently nullified. There's a lack of speculation about what happens to testosterone bound to SHBG, with the presumption being that there is no further effect. According to the free hormone hypothesis, only free testosterone, non-bound by SHBG, can diffuse through the cell membrane, bind to the androgen receptor, translocate to the nucleus, and render its cascade of effects. A deeper understanding of SHBG proves that the free hormone hypothesis and the medical community's understanding of SHBG is facile, oversimplified, which would be used to mischaracterize, mistreat, and misdiagnose hormone deficiency for the next 5 decades and counting. I would like to get into some more research on the free hormone hypothesis and how it is just facile. I'm just going to read a couple quips from this study and put it all in the context. On the basis of an appraisal of the literature, as well as experimental data, we have shown the assumptions of stoichiometry, binding dynamics, and the affinity of prevailing models of testosterone binding to sex hormone-binding globulin and human serum albumin are not supported by the published experimental data and are most likely inaccurate. This reviews some of the guiding principles for the application of free testosterone measurements in the diagnosis and treatment of patients with androgen disorders. The growing number of testosterone prescriptions and widely recognized problems with the direct measurement, as well as the computation of free testosterone concentrations, render this critical review timely and clinically relevant. This whole thing just kind of shits on free testosterone measurements. We get a lot of context about why the free testosterone measurements are just inaccurate, whether it be the calculation or the equilibrium dialysis, the direct test method. Let's see, going down here, this is actually just an interesting side note. This is kind of what is taught or what is understood, that SHBG is inhibited by insulin. And although insulin is a good biomarker for understanding if your SHBG is going to be crushed, it turns out that it's not insulin itself that is actually inhibiting the SHBG production. So SHBG production in the liver is inhibited by hepatic lipids and by tumor necrosis factor alpha and interleukin-1 rather than insulin directly, which was reported previously. Thus, the low SHBG levels seen in obesity and diabetes are most likely the result of low-grade inflammation and increased amounts of hepatic lipids rather than high insulin levels. Silva and Hammond have shown that thyroid hormones increase SHBG production indirectly by increasing hepatic nuclear 4-alpha gene expression, which is a major regulator of SHBG transcription. So later, when we go into ways to increase our SHBG, I'm going to include this as one of them, that thyroid hormones do help the increase in production of SHBG. So here's something that a lot of people don't know. There are more binding proteins than just SHBG and albumin. CBG is corticosteroid binding globulin, and this bonds like cortisol. But in here, it says some data indicate that CBG binds up to 4% of circulating testosterone. So up to 4%. They say that free testosterone is about 2%, of the total testosterone in your blood, right? Nobody's talking about CBG binding testosterone. So this is another reason. And it's certainly not in the calculation to get the testosterone. So when you have the calculated testosterone, it calculates it. It has this algorithm that calculates your testosterone from total testosterone, SHBG, and albumin. It certainly doesn't take into account CBG. There's another binding protein called orosomucoid that also binds testosterone. Some studies have said up to 10%, even maybe even more. Nobody's talking about orosomucoid actually binding to testosterone. I mean, we don't even know what they do with them. It's complicating factors that nobody's talking about. So it's hard to take a free testosterone level that doesn't incorporate any of these and say that any free testosterone calculation is accurate. Okay, what I want to say first here, I think, is this deeper understanding of SHBG. Again, the medical community believes that one testosterone molecule binds to one SHBG. Studies demonstrate that SHBG is a homodimeric protein consisting of two identical protein subunits, each with a testosterone binding domain, allowing SHBG to bind two testosterone molecules. I'm going to say that again because it's important. Nobody says this. You don't hear this anywhere. Each SHBG binds two testosterone molecules. When a second testosterone binds to SHBG, it binds with allostery, which means it undergoes a conformational change that may alter its binding affinity, making testosterone able to dissociate from SHBG. Jay, I know you have some things on allostery. Do you want to talk more on SHBG binding with allostery?
I think we should tell people what allostery is in the first place, which is basically a lot of these molecules have two binding sites on them, where the first one's called the primary binding site and the other one's the allosteric binding site. And so that's not what SHBG has. That's what's so interesting about SHBG is it behaves allosterically despite the fact it is not an allosteric molecule by its standard way of looking at it. So normally when something would bind to the allosteric site, it would change the way the primary site behaves, change the shape. So then it receives a different type of molecule. But in SHBG's instance, it actually can bind calcium, zinc, testosterone, DHT, estradiol. And for each one of those things that enters the main domain loop at the front, when it binds, it changes the other one. So that it starts off with two identical disulfide bridges, but then when something binds, it changes the other side. Vice versa. Whenever something enters one side, it changes the other one. And so you can see a visual of the loop. An estradiol can bind at the backside at the other loop, and it'll change the opening on the front to be different. And that change makes its binding affinities change as well. And so what you were talking about, where the first one's already filled, when the second one hits, it changes the one that's already bound so that its affinity changes.
The whole shape changes. That's what a conformational change means, right? Is the whole shape changes, and then it also changes the binding affinity. So this also means, right, Jay, that when the classic notion of SHBG binding testosterone, they say, oh, testosterone binds the SHBG very tightly, and that's it. And then they don't really explain what happens to it after that. Like, I don't know. The thought is that it just disappears, I guess. I don't know. But the idea is when this conformational change, it doesn't necessarily bind to it as tightly and may allow for it to release, because SHBG is a transport protein. It's supposed to transport testosterone. Testosterone is produced in the testicles in men and in the ovaries and adrenal glands in females. But there's androgen receptors all throughout your entire body, including your brain. So we need something to transport it there.
And there is a spot where zinc can land in it. And no one talks about that either.
Yeah. And zinc, what does it do? It actually inhibits if I remember correctly, it inhibits the binding of androgens to the SHBG, right? It actually inhibits it, probably to allow some SHBG to bind to estrogen, I would imagine.
Yes, I'm showing estradiol binding to SHBG is nonlinear, and the apparent KD changes with varying estradiol and SHBG concentrations. And estradiol's binding to each SHBG monomer differentially alters the conformational and energy landscape of both monomers, which is what we've already been talking about. There's this idea that it's like a little prison cell for testosterone. That's how these people talk about. Like, we have this whole mountain of information we've learned throughout this research project that just these urologists are like, yeah, it's a little mobile execution chamber for testosterone. It just grabs it and then it's gone forever.
Yeah,
that's all it does. What the hell?
But yet at the same time, they admit that it's a transport molecule, right? So how can it transport if it just imprisons it, and then it doesn't make any sense?
Yeah, right? We've got like at least 50 pages worth of stuff that we found here, and I've never heard more than one sentence.
Yeah,
from a medical professional.
Yeah. It's crazy. Yeah, and stay tuned, folks, because it gets more and more crazy. Okay, let's go to role as a transporter protein, right? SHBG is universally known as a transporter protein. Testosterone produced in testicles, ovaries, and adrenal glands in females requires SHBG to transport two androgen receptors throughout the entire body. If SHBG permanently inactivated testosterone, it would act as a suicide or antagonist protein. However, testosterone may dissociate from SHBG to be utilized by cells, making the total testosterone concentration bound by SHBG a more important metric. Additionally, SHBG-bound testosterone are utilized through two main mechanisms. We're going to go over those, but I want to show you this information in the study so you don't think I'm just making this stuff up. Subsequently, the resolution of the crystal structure of the N-terminal ligand domain of SHBG in the early 2000s revealed that dimerization and steroid binding domains of the homodimeric SHBG molecule are distinct and that both monomers with the complex are capable of binding sex steroids. Go down here. The binding affinities of the two binding sites on SHBG dimer were not identical. I just wanted to show you that so you don't think I'm making up that SHBG has two binding sites. And here's a graph that kind of illustrates it, right? So we have, SHBG bound by testosterone. This is the linear model, the kind of the linear idea, but this is more like what it does is testosterone binds to one SHBG and then changes the conformation. They have different binding affinities. When one is diffused, it can, again, change the conformation, change the shape, change the binding affinity. Cells use testosterone-bound SHBG in multiple ways. Again, when we say that cells use testosterone-bound SHBG, I don't want to hear this crap anymore about how free testosterone is the most important metric. We're going to see more and more as we go on that SHBG is very important, and it's utilized through several different mechanisms. The amount of total testosterone you have is necessary, and the amount of testosterone-bound SHBG is also very important. No more. I don't want to hear any more about free testosterone is the most important metric because the Endocrine Society said it. We're not regurgitating the Endocrine Society anymore.
So the most important metrics is looking at what androgens are supposed to be accomplishing in your body and saying, is it being accomplished?
Mm-hmm.
Like, what if you elevated clotting factors? You need more androgens to bring those down. Like, there's so many things you can look at. Are you waking up with erections? No, then you need more androgens. Like, there's so many things that matter, and free testosterone is just not one of them.
Yeah. I mean, the concept of free testosterone is important, but it's not the most important thing. And the measurements can be dramatically off. So all the measurements. So that's why it's better just to look at a total testosterone to SHBG ratio, right? We want that ratio to be healthy. Both need to be at adequate levels. Both need to be in a certain ratio with each other. That's different for everybody. We'll go on and talk about the mechanisms by which cells use SHBG-bound testosterone. This will show it. An endocytic process mediated by megalin. So SHBG-bound testosterone is internalized into the cell through an endocytic process mediated by the membrane protein megalin. Inside the lysosome, testosterone is released from SHBG at a low pH, acidic environment, and binds to the androgen receptor. So this is the classic thought, right? The first one, A here, is the classic thought where testosterone binds to SHBG, and then the free testosterone is the only thing that goes into the cell. It binds to the androgen receptor. Now, this is going to be important right here. See these coactivators? You notice that they have a coactivator in here that has to chaperone and translocate the testosterone-bound SHBG into the nucleus to bind to the DNA and have its cascade of effects, where it actually transcribes into mRNA and translates into a protein that has a cell-specific effect for the rest of your body. But here is B. Here's another way. So there's a protein on the cell surface called megalin. It ensnares a SHBG-bound, testosterone-bound SHBG through an endocytic process, which means that it just swallows it and then internalizes it into the cell. And then a lysosome takes up this. Lysosomes normally, they're actually there to kill anything or get rid of anything that is foreign. Any pathogens or any exogens that are foreign to the cell. So it takes up this SHBG-bound testosterone. Now, in the acidic pH, the bonds that are used to bind the testosterone to the SHBG, they are loosened and actually like dissolve, and it allows the testosterone to dissociate from the SHBG, and then it goes in and binds to the androgen receptor and has the classic genomic effect right here, right? Again, I don't want to hear any of that free testosterone is the most important thing because it's the only thing that's utilized. SHBG-bound testosterone floating around the cell can be utilized by cells. Here's one of the ways. Then we get into the very complex and the very deep, meaningful way. SHBG is important. SHBG binds to a specific receptor on the cell membrane. So SHBG binds to a receptor, an SHB receptor on the cell membrane, and then binds to a steroid hormone that transduces its signal via a G protein. G proteins are just kind of signal proteins in the cell that they help with what's called crosstalk, right? Or cell signaling. They signal something outside the cell, allows it to signal a process inside the cell. And in this case, it effectuates it. This complex activates adenyl-cyclase, generating CAMP or cyclical adenosine monophosphate, which affects the transcriptional activity of classic intracellular steroid hormone receptors. Okay, so let's go back and let's look at a picture. Okay, so here's kind of a picture of SHBG receptor complex. So here's the outside of the cell. There's a receptor on here. The SHBG connects to it, right? The empty SHBG, this is what's important. The empty SHBG connects to this. If the SHBG has a testosterone in it, then it cannot bind to this receptor. So empty SHBGs bind to this receptor cell. Once they're bound to this receptor cell, they're coupled with this G protein that can signal inside the cell. And then when a testosterone binds to it, it can signal inside the cell. And let's start to look at what that does. SHBG can only bind to RSHBG when unligated. Once unbound, it can then bind to a steroid hormone to initiate a non-genomic cascade of effects. So there's a difference between genomic effects and non-genomic effects. Genomic effects are the classic way we talked about when testosterone diffuses into the cell, binds to the androgen receptor, and then the coactivators translocate it to the nucleus. It binds to the DNA, transcribes into mRNA, and then translates into a protein. That's the genomic effect. But when you bind to the DNA, that's genome. That's a genomic effect. A non-genomic effect is when we have a receptor cell outside the cell that just sends a signal and effectuates some change inside the cell. That's non-genomic. Not all binding steroids effectuate a reaction. For example, 2-methoxyestradiol, a biologically inert metabolite of estradiol, binds tightly to SHBG and inhibits SHBG binding to RSHBG, potentially acting as an antagonist, right? So this is a metabolite of estradiol. This may be one of the reasons why too much estradiol causes side effects that mimic low testosterone, right? When we have too much estradiol, we get fatigue, lethargy, erectile dysfunction, things like that. It could be because this SHBG signaling process is very important to the testosterone pathway. And if we block that, we're going to see later that we will have signs of hypogonadism or hypoandrogenism.
Where does 2-methoxyestradiol come from? Because normally it gets hydroxylated first, so that would be 2-hydroxymethylestradiol. This is just straight to methylation. That's interesting.
Yeah, it just indicated it was a metabolite. Effects at CAMP and PKA. One effect of testosterone binding to an unligated receptor bound by SHBG is the increase in intracellular CAMP, which then increases intracellular PKA. CAMP, cyclic adenyl monophosphate, it increases intracellular protein kinase A, right? These are two just signaling proteins that we'll get to it, but they actually act to phosphorylate things. Phosphorylation allows the coactivators, which remember I said earlier are very important. Phosphorylation allows the coactivators to attach to the testosterone-bound androgen receptor and then translocate it to the nucleus. When the testosterone binds to the androgen receptor, it doesn't automatically just intuitively flow towards the DNA, towards the nucleus and bind to the DNA. It needs to be chaperoned there. It needs to be taken there by a lot of coactivators or chaperone molecules. There's over 100 of them. Last checked, and they don't even know about all of them. But over 100 of these things have to come and take it to the nucleus and open up the DNA and then bind it to the DNA at the androgen responsive element. This takes, again, over 100 chaperone proteins. The phosphorylation allows this to happen. Okay. SHBG serves as a conveyance for non-genomic mechanisms that increase CAMP, which phosphorylates androgen receptor co-regulators and coactivators. This phosphorylation allows coactivators in the cell to stabilize the translocation of the testosterone-bound androgen receptor to the nucleus, facilitating the binding to the DNA for transcription to effectuate the genomic cascade of effects. Without phosphorylation of the co-regulators, the testosterone-bound androgen receptor may attach a co-repressor or may not facilitate the translocation to the nucleus to bind to the DNA. This may leave the testosterone-bound androgen receptor in limbo, so no new androgen receptors can be genomically translated. Okay, so we're going to take a look at, first, let's go back and look at CAMP. CAMP is widely distributed and functions as a secondary messenger for a variety of hormones. Its effects are partitioned so that its accumulation does not lead to promiscuous activation of numerous pathways, but rather bears a specific relationship to the stimulus which caused its appearance. This is super interesting because now we're saying that, so for instance, when testosterone binds to the SHBG, it has a specific function that's aimed at the androgen receptor or the testosterone function. When, estrogen binds, it has a specific function that aims at estrogen. So the different ligand that binds to the SHBG will have a specific function. A lot of our information that we know about androgen receptors comes from the study of prostate cancer, because prostate cancer is such an issue. They've poured a lot of money into understanding prostate cancer and the androgen receptors that the whole hormone response that secretes PSA and what's going on with prostate cancer. So we have a lot of our information comes from that because there's been a lot of studies on it. Compared to that seen in the culture LNCAP cells, which is a prostate cancer cell, estradiol alone had no effect on PSA secretion, but it caused an increase equal to DHT if the prostate tissue was first loaded with SHBG, if RSHBG was occupied by SHBG. So what this is saying here, and we can go down here and further look at this, thus estradiol activates a typical AR-mediated event, PSA synthesis and secretion, by activating SHBG and demonstrates crosstalk between a steroid hormone engendered event at the cell membrane and a classic intracellular steroid hormone receptor. So this is showing and kind of proving that, this is kind of a side note of this whole thing, but this is kind of showing through this SHBG mechanism, this is proving that SHBG does have some aspect in anabolism or the androgen cascade of effects, right? So when, there's a lot of people say, oh, estradiol is anabolic. Well, here's a method in which it would be anabolic. This mechanism, we're going to look at a picture so we can get a very clear idea of how SHBG facilitates the efficacy of the testosterone's cascade of events. Non-genomic steroid activity typically involves the rapid induction of conventional secondary menstrual signal transduction cascades, including increases in free intracellular calcium and activation of protein kinase A, protein kinase C, and MAPK. These are all secondary messengers that influence the internal activities of the cell. So interestingly enough, let's go over this again. So let me educate you on something that's super interesting for people who really understand this. Non-genomic activity involves the rapid induction of conventional second messenger cell transduction cascade, including increases in intracellular calcium. So when we increase cellular calcium, this is what increases the sodium potassium pump, which increases muscle size, right? So the function of actual muscles filling with fluid, getting bigger, and this would also allow the calcium to make the contraction of the actin and myosin even stronger, right? So we're making each muscle cell fill with fluid, get bigger, and the contraction stronger. This is what calcium Ca2 plus would do. So interestingly enough, oxymethylone, or anadrol as better known, is a androgen that does not diffuse through the cell and does not activate the classic steroid hormone cascade. It does not diffuse through the cell. It only binds to the receptors, either the SHBG receptor or there are androgen receptors in the cell membrane as well. It only binds to the androgen receptor in the cell membrane and has the non-genomic effect of increasing muscle size of the Ca2 plus, increasing the muscle size, increasing the contractile strength. That's how anadrol makes you so big, so fast. Even oxandrolin's main function goes to bind to these cell membrane receptors. Anadrol from oxandrolone, you can gain significant weight in just like 2, 3, 4 days of use. And that's all through this non-genomic effect, all these receptors. Why is this so amazing? Because if you go to your doctor and tell them that there's androgen receptors and SHBG receptors in the cell membrane, they're going to look at you like you have no idea what you're talking about, like you have two heads, because they've never even heard of this. They don't understand it. We're talking about something that it goes way beyond what is understood, even among the professionals who are guiding you through these protocols. Right? The initiation of the second messenger cascade may ultimately serve to modulate the transcriptional activity of the androgen receptor or other transcription factors. So right here, we're saying that the secondary messenger, it alters the transcriptional activity, which transcriptional activity is actually the androgen receptor binding to the DNA and having its cascade of effects. That's the transcriptional activity. When you transcribe when the androgen receptor binds to the androgen responsive element on the DNA, it transcribes into mRNA. mRNA then translates into a protein that has an effect for the rest of the body, right? And it's cell specific as to what that protein is. So the transcription factors are, if it affects the transcription factors, it actually affects the genomic effect. The non-genomic action of androgens has been implicated in a number of cellular effects, including gap junction communication. Listen to this. This is interesting. Androgens has been implicated in a number of cellular effects, including gap junction communication, aortic relaxation, and neuronal plasticity. All very positive things, right? These are positive things, making your synapses fire better, aortic relaxation, making your aorta bigger so more flow can go through it. And the neuronal plasticity, that's, again, improving synaptic events so you can think better. However, some of these experiments were conducted at unphysiologically high levels of androgen. The biological relevance of such observations is not clear, and these effects are not included in this review. Okay, so they found benefits from high dose supraphysiological doses of these androgens. And because it's supraphysiological and they think that no one will ever get there, they just excluded it from this study. Right there, but right here, they're admitting there is benefits to having supraphysiological levels of androgens. Why not study that? They didn't. This is part of the problem, is they just throw that information out. Membrane receptor mediated events can be stimulated by T coupled to high molecular weight compounds such as bovine serum albumin that retard its diffusion across the cell membrane. Okay, right here, we're taking a look at what one of the major functions of albumin may be. Again, it's noted as a transport protein, which is true, but also it looks like it's one of its main effects is to keep testosterone, all of the testosterone out of the cell, because albumin-bound testosterone can bind to the SHBG. It can bind to the SHBG and then have the non-genomic effect. So it looks like your body has made it important to keep some of the testosterone, in fact, most of the testosterone outside of the cell. It keeps it there by binding it to albumin. This is like a mechanism of albumin. So this shows you how important this non-genomic effect is, because there is actually a mechanism to keep testosterone out of the cell so that it stays on the extracellular level. Consistent with this mode of action, T and DHT can activate CAMP and PKA through the sex hormone-binding globulin receptor. Androgens have also been observed to stimulate an elevation in intracellular CA2+ through the G-coupled receptor, although it remains to be determined whether this receptor is distinct from the SHBG receptor. What they're saying here is that they don't know if there's actually an androgen receptor in the cell surface. They know this SHBG receptor exists. There's another G-coupled receptor they think could be an androgen receptor, or it could just be the SHBG receptor. This study is a little older. It seems nowadays they have, because I hear so much talk about it, that they have confirmed that there is an androgen receptor also in the cell receptors. So we'll go with the assumption that there is. At the time of this study, they weren't sure if they were different. The non-genomic rapid stimulation of the second messenger cascades by androgen may ultimately exert a biological effect through modulation of the transcriptional activity of the androgen receptor or other transcription factors. Such modulation may occur through direct phosphorylation of the transcriptional activators or their co-regulators. Just want to show you I didn't make up what I said earlier, what we're about to go over. Okay, so here's the picture. Here's the cell membrane. Here's outside the cell. We have testosterone. We have SHBG bound to a receptor. We have testosterone binds to it. Let's just take a look at this middle part right here. The rest of it gets kind of confusing. This is like, all this stuff is the other G-coupled receptor, and possibly another androgen receptor. But here's the testosterone and SHBG. So testosterone binds to the SHBG. From that signal comes increased CAMP and PKA, which again, remember I said how important the androgen receptor co-activators are. These things right here have to chaperone it to the nucleus. If they don't, then it can't get there. It doesn't have its own motor. They need to be chaperoned by this. The PKA phosphorylates the androgen receptors, actually phosphorylates the coactivators, and the coactivators can then bind to the androgen receptor and take it to the DNA, where more coactivators are needed to help it bind to the DNA. They have to put it in place and help it bind to the DNA properly. If it doesn't bind properly, you don't get the right mRNA transcription, and you have like a screwed up protein. Again, when I said here that the coactivators are necessary to translocate it to the nucleus to bind to the DNA, if these aren't phosphorylated and they don't bind to it, then this testosterone-bound androgen receptor will just sit here in limbo. Now, the androgen receptor is not set to replicate or regenerate until it binds to the DNA. Part of this transcription, part of testosterone-bound androgen receptor binding to the DNA, it also promotes the production of a new androgen receptor, but not till it does this. So when the androgen receptor is just sitting here in limbo, then you're not replenishing the androgen receptor, you're just taking it out of circulation. It's not doing anything, just sitting here in limbo. And now you're taking away androgen receptors. So if you have no SHBG up here, you have no phosphorylation of the coactivators, then you can have a whole bunch of testosterone-bound androgen receptors here doing nothing, not having their cascade of effects. And this is why we're going to start to see that people with low SHBG have symptoms of low testosterone. They have hypoandrogenism because this cascade is not happening. SHBG is very important. Jay, do you have anything else that you want to...
What you just said was so big.
Yeah, it's huge.
Because a urologist will look at your free testosterone and go, "You're in range. Fuck you. Get out of my office. You're getting nothing."
That's exactly.
And here we are showing that with like single digit SHBG, you're in a really bad position.
Yeah,
it's bad.
Yeah, and this is also why, because this mechanism is so important, the whole idea that free testosterone is the only important thing is absolutely ludicrous. Because if you have, well, we're gonna look at a case. We're gonna look at a case of somebody who had, and there's only been one recorded case of somebody who had next to no SHBG. They have a mutation that gives them no measurable SHBG.
Oh, I got a whole section on the genetic mutations with SHBG also.
Yeah, right. There's a lot of them, right? Yeah. So I'll go over that real quick, Jay, and then you can just take over and keep going with the rest of the stuff. I just want to finish up a couple things here. There's not too much more. Androgens and E2 are able to rapidly induce CAMP. So the genomic effect takes time. When testosterone binds to the androgen receptor, that takes time. It's a longer event. That's why some of the benefits we see from testosterone take months and months, right? The fast effects that you see when you take oxandrolone or anadrol or D-bol or whatever, and you can take it 2 hours before the gym and have a noticeable pump in the gym, like 2 hours later, that's from the non-genomic effect, because it's very quick, it's very rapid, it can happen in minutes, right? You can start to increase your muscle, fill up your muscles with fluid, increasing the contractile strength in minutes, right? Well, it's right here. E2 can induce CAMP within 5 to 15 minutes. In serum-free media or in fetal calf serum containing media from which SHBG has been removed, the addition of SHBG and presence of cellular SHBG receptors is necessary for steroid induction of CAMP. So without SHBG, no CAMP. The induction of CAMP by SHBG results in the activation of PKA. Without SHBG, no CAMP, and therefore no PKA. Androgen receptor transcriptional activity is enhanced by PKA stimulation, even at very low levels of androgen. In organ cultures of human prostate explants, the DHT induction of the androgen receptor target gene prostate-specific androgen. So the PSA, the prostate-specific androgen, is the genomic effect in the prostate. It releases this prostate-specific antigen. Target prostate-specific antigen can be mimicked by stimulation of the SHBG-PKA pathway. PSA expression in the system can be induced by treatment with both SHBG and E2, whereas SHBG and E2 alone had no effect. Right? So SHBG is necessary in this androgenic pathway.
I wanted to really bring a light to this, because we're being led to believe SHBG is just this stupid thing that just binds testosterone and does nothing else. Mm-hmm. Look at how deep we are right now. We're like down in the hole. Like, look at what SHBG is doing. It does so much.
It's like absolutely necessary to this whole process, right? It's absolutely necessary. All right. E2 SHBG induction of PSA appears to function through transcriptional activation of androgen receptor in the absence of exogenous androgen, possibly through stimulation of PKA. So this is more evidence that the E2 pathway can activate the androgen hormone cascade. The reason when we have prostate cancer, the typical thing they do is give you androgen deprivation therapy to remove all the androgens because they think that androgens facilitate and increase the prostate cancer, and they make it worse. The contemporary knowledge is showing that testosterone actually doesn't make prostate cancer worse.
The thing is, it slows it down though when they take it away, but then the adaptation kicks in.
Yeah. So this
right
adaptation,
going where it was.
right? So there's like a mutation that occurs because we have evolved. Our whole body is beautiful, and the symphony to deal with whatever comes its way, to adapt. So when we have low hormones, our body adapts by allowing us to bypass the androgen binding to the androgen receptor, translocating in the nucleus and having the cascade of effects. Here's one of the ways that estrogen can do it. So when there's certain mutations that occur because of low testosterone, there's other ways that we can exact the hormone cascade, the androgen receptor cascade. And that's when you give somebody with prostate cancer androgen deprivation therapy. If it doesn't remove it, if it doesn't work, which most of the time I'm starting to read that it doesn't, then you come back with this really aggressive form of prostate cancer that is immune to androgen deprivation therapy.
Although it's like a prostate cancer cell is a prostate cell, so it behaves the same way a prostate cell does in this context, because people with low testosterone can still have BPH because estradiol takes over.
Yeah.
And then they can have estrogen receptor alpha stimulation to the point where they get BPH despite having double-digit testosterone.
Yeah.
But prostate cancer cells have this same adaptation because that's where they came from. Like if it was a lung cancer cell in your prostate, it wouldn't behave that way. But these are actual prostate cells. That's why they do that.
Yeah.
So that's why BAT therapy is so superior, because you keep them dependent on the androgen and then pull it away. So it keeps it from growing as fast while you're radiating it, hitting it with chemotherapy, whatever.
Yeah.
Right.
I think I sent you guys a video, right, of the urologist, it's Rena Malik, and I forget his name, but another urologist he talked about how he gives all of his prostate cancer patients testosterone, and it doesn't make any of them worse. Like, he's got a whole video where he talks about it. He goes, I don't even know where this all came from, that testosterone can make prostate cancer worse. He does it to all his patients, and it's actually beneficial for them.
I'd say it's because of all the things that androgens do in your body that you don't want to lose. Like, your immune system needs it. Why would you shut your immune system down when you're in the middle of battling cancer and you've got radiation and chemotherapy causing damage in the body that needs to be fixed?
That's exactly right.
Like, you got to look at the net effect, right?
Yeah, that's exactly right. Normally, weak adrenal androgens or E2 may contribute to androgen receptor transcriptional activity through stimulation of the SHB signaling. Just kind of more to show you that I didn't make all this up. This has been studied. Therefore, it is possible that androgen SHBG stimulation of PKA may result in an alteration of the phosphorylation status of the androgen receptor and the androgen receptor co-regulators, and thus modulate androgen receptor transcriptional activity. This is exactly what I was talking about in that picture up above. This is one more thing just to show. At this time, they weren't certain if there was androgen receptors in the cell membranes or not. However, it has not been determined whether these non-genomic effects are mediated through a membrane androgen receptor or acting through the SHBG or a C source kinase androgen receptor complex. At this time, they weren't sure if the androgen receptors actually existed if it was all just this SHBG mechanism. Contemporary knowledge is really leaned towards that there is androgen receptors in the cell membranes. So this is going to be a study, or one of the only people who was found that had a mutation that caused non-detectable SHBG. Probably there's only one person who does this, probably because it's so important that if you're in the fetal stage and you have some sort of mutation that doesn't allow you to have SHBG, then you probably don't survive, right? So there's probably the reason we only have one case is because you don't survive if you don't have SHBG. Probably. That's just my guess. I don't know that for sure. Okay, the mathematical models used to calculate free plasma androgen or estrogen levels currently rely on SHBG measurements obtained using immunoassays. This is another thing that shits on free testosterone. And they are based on the assumptions that all SHBG molecules react similarly immunologically and have identical steroid binding properties. These assumptions are fallible, however, because some SHBG variants are not recognized in immunoassays, while others have abnormal affinities for sex steroids. So we're saying that the tests themselves may not recognize some of these variants of SHBG. Including the SHBG P156L variant with a reduced affinity for testosterone that is present in 1% of Caucasians. 1 out of every 100 people has this, where you're not binding very strongly to testosterone, and increases the free fraction of testosterone in the blood of male carriers. These findings highlight the pressing need for sensitive mass spectrometric methods to measure both total and free sex steroid levels in the blood. Okay. That was more about this. Here's the actual part where we study a person with no detectable SHBG. But a rare missense genetic mutation that produces a secretion defective SHBG variant was recently reported in a young man and his sister, both of whom were homozygous for the mutant SHBG allele and had no detectable SHBG in their blood. As expected, plasma testosterone concentrations in the male proband were well below the normal range. Okay, so explain that. When you have a lot of free testosterone, there are androgen receptors in your hypothalamus, and this is how your hypothalamus reads your testosterone level. If you have a lot of free testosterone, there's a lot of testosterone to bind to the hypothalamus, and therefore your hypothalamus shuts off its production of gonadotropin-releasing hormone, so it doesn't stimulate the pituitary gland to produce luteinizing hormone, which then will not stimulate the testicles to produce testosterone. So high free testosterone, you're going to shut that off. So if you have no SHBG, you're going to have low testosterone because you're going to keep shutting off your hypothalamus from producing more testosterone, right? So they have low testosterone. As expected, plasma testosterone concentrations in the male proband were below the normal range, yet his free testosterone levels were normal. Clinical assessments indicated fatigue, overt muscle weakness, and low body weight and other symptoms of hypoandrogenism. But gonadal development and sperm production function appeared to be normal. So again, I don't want to hear this crap about free testosterone is the most important metric. Here's somebody who had normal free testosterone, no SHBG, had all the symptoms of hypoandrogenism, low testosterone, hypogonadism, right here. So here's this is just proof that SHBG is that important. What is interesting is that SHBG doesn't appear to have an effect on the development of the gonads. Although this report provides an indication that plasma SHBG is not essential for male reproductive development and sperm production, the proband's clinical phenotype suggests a more direct role for SHBG in supporting anabolic activities of androgens. SHBG supports anabolic activities of androgens. Said it right there in a study. Okay, Jay, do you have some more stuff on SHBG mutants?
I got a couple of studies on it, actually.
Okay.
So there's several single nucleotide polymorphisms in the human SHBG gene. The N-terminal laminin G-like domain of SHBG includes binding sites for calcium, sex steroids, and fibrillin family members, as well as dimerization domain. And 8 out of 18 uncharacterized non-synonymous single nucleotide polymorphisms within the domain alter the production or biochemical properties of SHBG in ways that were not previously recognized. So we'll go through each one here. This one is an O-linked glycylation at THR7 is disrupted in SHBG T7N, whereas abnormal glycylation of SHBG G195E limits its secretion. 3 SHBG mutants, R135C, L165M, and E176K bind estradiol with abnormally high affinity. SHBG R135C also has an increased interaction with fibrillin 2. 2 different substitutions within the dimer interface at R123H and C reduce the affinity for DHT while increasing the relative binding affinity for estradiol. SHBG T48I is defective in calcium binding, which leads to a defect in the dimerization, reducing affinity for sex steroids and an enhanced interaction with fibrillin 2, which can all be restored with calcium supplements taken over the counter.
No,
yeah, let's go and look at that one again. That's so I mean, this just sounds like
Thinking of some of
a
my
barrage
current
of
patients right now.
what?
I'm like thinking of some of my current patients right now. I'm like, hey, I'm going to get back to some of them who are having problems with their libido and say, hey, you need to take calcium.
Yeah, I'll read that one part just real quick again.
Yeah.
Two different substitutions within the dimer interface reduce the affinity for DHT while increasing the relative binding affinity for estradiol.
Mhm.
And so SHBG-48I is defective in calcium binding.
Mhm.
And calcium binding is important for SHBG because it has a site for calcium because it's a Ca2 plus promoted dimer. And then as a zinc slot. So in this genetic mutation, the calcium binding site is messed up,
Mhm.
which screws it over. But apparently they're saying you can just take calcium supplements and it's been shown to help
Mhm.
for some
So
reason.
I want everybody who has a really hard time dialing their libido in, because it's rare, but it happens. I want you to listen to this because this could be a reason, all these things that Jay's saying right now, because it could be a reason why you're having a hard time dialing your libido in. If we're having problems with DHT binding to SHBG because you have a SHB variant, what we show? 1 out of 100 people has it, has the one mutation that I showed you. So I mean, if you have one of these SHBG mutations, one of these variants, this could be why you have a problem with libido.
This shows the importance of testing too. Imagine if we were able to give people genetic testing for these SHBG
For the variant.
mutations.
Yep. Then you would understand, and you have a better understanding of what you need to do. So why do some people like do so well with massive doses of DHT, right? Probably because they have one of these variants, and
Yeah.
they need a ton of DHT to be able to bind to the SHBG to have this genomic effect.
This like hurts me in the feelings because I think about like imagine you've been having low hormones and no one will listen to you. Everyone's gaslighting you. You
Mhm.
finally do get on hormone replacement and then it doesn't work. And
Yeah,
then you're still being gaslit because people don't know about these mutations. And then your
yeah,
TRT doctor's like, we've got your testosterone at like 2000 already, dude. It's not going to work. Like, I
yeah,
guess you're a lost cause. When in reality, it was just a SHBG mutation
yeah.
and they may never find out.
Mhm.
It just shows you the deeper you go,
Yeah,
like there's so far to go to get dialed in sometimes, and
yeah,
it's so complicated.
yeah. So calcium for some people, sometimes we need to just push the DHT as high as we can.
Mhm.
All right.
We can talk about pregnant women in
Sure.
SHBG. They have
Okay.
some wild change. SHBG is doing things for them that is by as part of the pregnancy system.
Okay.
So once again, we see that SHBG is more than just a prison cell for testosterone. It
Mhm.
actually does. So let me see this study here. It says, I'll just read the quote because it's actually written pretty easy to understand. They
Mhm.
say, we collected blood from 60 different women on 3 different occasions during their pregnancy. We observed a 1.7-fold increase in testosterone concentration in their serum. Concentrations of SHBG went up by 5.6. The major increase of 6.8 in estradiol in serum occurred within the first 4 months, followed by a 4.8-fold increase by the time they were at term. Mean concentrations of progesterone, 17-hydroxyprogesterone, and androstenedione in serum increased by 11.9, 3, and 1.3-fold respectively, whereas concentrations of DHEA sulfate fell by 50%. Mean serum prolactin concentrations went up by 3.8 during the first trimester and again within the final 24 weeks. So we see that SHBG went up by 5.6.
Hmm.
So that means you take their SHBG and you multiply it by
Multiply.
5.6.
That's crazy. Wow.
Yeah. So obviously it's needed.
There's some important mechanism with that. Yeah. That's
Yeah.
interesting.
And you might think it has something to do with all that estradiol increase as
Yeah.
well.
Right.
Because their estradiol went up 6.8 fold
Fold.
within
Yeah.
the first 16 weeks, followed by an additional 4.8, which means you take the original value times that number and then multiply it again. So
Yeah.
it's not the original number times 4.8 again, it's the new number. And then you do that again, it's massive
Yeah.
increase.
Which shows you that your body is trying to maintain a certain ratio, right? So your body is trying to do that naturally. So it's not about having just the hormone. There's cases where you do need the hormones, but you also need the SHBG in a certain ratio with it to have optimal effects, right?
Yeah. And I found a study that showed transdermal estradiol has no effect on SHBG, but oral estradiol hits the liver in such a high concentration that it stimulates the liver to make more SHBG.
That's interesting.
And so that we had talked about that previously. We were wondering, why do women have higher SHBG levels?
Mhm.
'Cause it's when the estradiol reaches the liver specifically.
Mhm.
So if women have a really high SHBG level and they're on oral estradiol for their HRT, they can switch to injections or transdermal, and their SHBG should come down
That
technically.
yeah, that makes sense.
And I got one more study on
Sure.
human neonates. SHBG levels in the umbilical cord blood are approximately 10 times lower than in the maternal blood. So SHBG is, just to put that in reverse, it's 10 times higher in the cord than it is in the mother's serum.
Yeah.
Um,
Wow.
Then increase to relatively high levels in infants of both sexes until the onset of puberty. So they're showing that once you're born, you maintain these really high SHBG levels until you get into puberty, and then it starts to come down.
That's really interesting.
It is, because you would never expect these values to get measured unless it was in this study. Because
Yeah, right.
I mean, we went our whole lives without ever
It's
getting a hormone
it's
test.
part of the problem with the lack of understanding of all these hormones is that we've never taken the data, right? Right?
Yeah,
Like no doctor was ever like, "Hey, let's just take the kids' hormone levels and their SHBG just to see."
yeah.
And therefore we have no data, and that's why they're so blind. That's why the entire medical community is so blind when it comes to these things, is because they never even consider it. But that's this is all interesting.
It'd be great if we had a full list of all the gene mutations for all these different things.
Yeah,
Like, get kids tested when they're little, and then they will know ahead of time. You have
yeah.
all these gene mutations that affect your SHBG, your receptors. I have another study about how they measure androgen insensitivity by using stanozolol. I can tell you this: the sex hormone binding globulin androgen sensitivity test has been used as a simple method to assess androgen receptor function. After a short-term oral administration of stanozolol, the mean nadir serum concentration of SHBG is used as a measure of androgen response. Did you know that?
Interesting. I didn't.
Yeah.
That is
So this is
interesting.
how they check for androgen insensitivity
Yeah, right.
syndrome. They can use stanozolol to measure because if you're insensitive to the stanozolol, your SHBG won't change.
Yeah, right.
That's pretty
Interesting.
cool.
That is really cool. It's really cool.
Yeah. So that just shows if people have dramatically high SHBG, they could lower it with stanozolol. And then if it doesn't lower, maybe you have an androgen
Yeah, that's right.
insensitivity.
Yeah. Because sometimes we give people like these pretty high doses of testosterone, and their SHBG doesn't really go down like it does for most people. And I'm just like, I mean, they've got to have one of these mutations, right?
Yeah. The
Like I never thought about it in that context till just now. See, look, I'm learning right here on the show, right here on the recording.
I do want to mention that in MC7 breast cancer cells, SHBG does something besides. Well, I keep bringing it up, like
Mhm.
it's so like it does more than just putting testosterone in
In
prison.
prison,
It-
yeah, I love
yeah,
how you frame that, because that's exactly what your doctor thinks. They think that
yeah.
SHBG just puts it in prison, and then, like, I don't even, why would you call it a transporter protein if it's just a prison protein?
So they have these MCF7 breast cancer cells, and when they add SHBG, the estradiol can no longer make them grow. So estradiol reduces the number of cells undergoing apoptosis. So that means that when the breast cancer is trying to be destroyed, the estrogen is keeping it from going into
Yeah,
apoptosis.
yeah.
But then when they add in the SHBG, this effect is ameliorated,
Mhm,
and then the apoptosis can continue.
mhm.
So that's amazing.
So, yeah, as we know, we've talked about before, estrogen receptor alpha is proliferative, right? So it would actually prevent apoptosis and allow proliferation, and SHBG can inhibit that. So, and that which is necessary. There's times when you absolutely need proliferation. There's times when you need to inhibit that. Great.
Another fun fact here is when you have men, specifically in this study, that have severe fatty liver disease, once the liver disease gets bad enough that it's end stage, it will affect your SHBG levels such that you end up with gynecomastia. Isn't that wild?
That is crazy. How does that work?
I'd have to open the study and read it real quick, but
Oh, no, that's okay. That's
basically
interesting.
they
Yeah.
said all the people underwent feminization once their liver got completely screwed
Because their SHBG went so high. I wonder if it's just because of that, because gynecomastia is a non-genomic event and it allowed all the non-genomic transduction of the secondary messenger. Interesting.
Yeah, and then in women that had liver disease, SHBG didn't change.
Okay. All right. So the conclusion and the importance of SHBG. SHBG facilitates the efficacy of testosterone in our blood, creating more sensitivity to its genomic effects. Humans have evolved the mechanisms to deal with both high and low hormones. If we take a step back and look at the big picture effects of SHBG, we can see that one of SHBG's purposes is to act as a defense mechanism against elevated androgens. It is not a coincidence that SHBG lowers in the presence of androgens and therefore desensitizes our genomic response to elevated levels of androgens. Okay, so let's take a step back. Let's take a 10,000-foot view and look at this. It's actually a beautiful, harmonious, symphonous mechanism. It's like the SHBG can be a defense mechanism against high hormone. When our hormones get too high, the SHBG goes down, which then reduces the non-genomic secondary messengers to facilitate the genomic process. And therefore, there's not as much transactivation going on so that the high androgens can't harm us. You can start to see that this is actually a beautiful defense mechanism. Maintaining healthy SHBG levels. Keeping SHBG within a healthy range is essential to maximize the effects of androgens. As we have stated, SHBG is important. So if you have high SHBG, it doesn't make sense to attempt to artificially reduce your SHBG with supplements or boron just to increase your free testosterone. Jay just went over a bunch of events where naturally your body will increase its SHBG to have more hormone signal transduction. Like SHBG is important for the hormone cascade. So your body will actually increase SHBG to increase the hormone cascade. Dealing with high SHBG is easy, but increasing low SHBG is difficult. If you have elevated SHBG, simply dose your testosterone to a healthy total testosterone to SHBG ratio. We get people with high SHBG, like, sometimes I'm a little jealous because it's really easy to deal with high SHBG. You just got to dose the testosterone to a healthy total testosterone to SHBG ratio. Some guys with really high SHBG, I have some guys with 60, 70 SHBG that just need really high doses of testosterone. Sometimes you have to go to 300 or even 400 to have that healthy ratio. Again, these are the guys who are on TRT and they still have a 60. I bet you they have one of those mutations because for most people, 200 milligrams per week of testosterone or a blood level of 1,000 to 1,500 will reduce their SHBG to the teens, 20 or to the teens usually. But some of these people we put on high doses and they still have 60, 70 SHBG. It's either like if you have a liver issue, but that's again, these guys don't have liver issues. So they have to have one of those mutations of the SHBG. Here are some ways to increase low SHBG. This is going to be kind of what everybody wants to hear because it's not uncommon problem that people have crushed SHBG. A lot of times when we go on cycles, we crush our SHBG. We need to get it back. I get all kinds of guys who come to me for help. They get consultations and they say, man, I was taking this, I was growing, everything was great. I felt great. I had a high libido, I felt amazing. And then one day, all of a sudden, the wheels just came off and my libido, my energy, I was fatigued, everything went to shit. They have symptoms of low testosterone again. Why? Probably because they went below this threshold of SHBG. And I can even give you some numbers that I see a lot. Again, this is a generalization. Everybody's different, but usually I see when people get below 12, generalized, is when they start having low androgen problems. Everybody's a little different, but sometimes like 12 and above is when people still seem to have enough androgen effects, the hormone cascade to allow them to have good effects. Again, this is generalization, but those are some numbers you can kind of look for. For these guys, a lot of times we have to reset. Sometimes I'll even say you got to stop your testosterone for a month. Let all your health markers reclaim. The auto-regulation of all the receptors come back, everything come back, and then we can start on a low TRT dose again. We can get all the health markers to resolve, and then people start feeling good again.
Have you ever had anybody with like the money to burn do SHBG testing along with orals and do do an SHBG test and then they run oxandrolone for a while and see how much it lowered their SHBG and how long it takes to recover? Like, because a lot of patients are using stanozolol and oxandrolone right now, and I bet most of them aren't getting regular SHBG testing because it's like $50, right?
Yeah, you're right. I mean, Like I put SHBG in all my tests because I want to see it. It's important. But you're right. Like a lot of people don't get a test or they don't keep an eye on it. But this is something that we can definitely do. You know what I think would be the most interesting is there is one company in Europe that sells recombinant SHBG. And if we could start testing these people with low SHBG, we could actually give them recombinant SHBG and see how that affects them, see if that cures all their ails. And you could give them the right kind of SHBG, right? Like if they have a mutation, you could give them a non-mutated form of SHBG. I think that could be a major answer for people. What I have to do is get a hold of this company because right now you can buy it, but it's super, super expensive. One of my plans is to get a hold of this company and see if we can really study this and maybe we can buy a certain amount of units if we can get the price way down to make it affordable. I think it could be huge getting recombinant SHBG. Okay, so let's take a look at some ways to increase your SHBG naturally. Reduce your sugar intake. So earlier we showed that it was actually like hepatic lipids, interleukin, and necrosis
factor.
Yeah, necrosis tumor factor that actually reduce it. However, I'm going to stay with insulin just because high insulin is a good biomarker to use to understand why your SHBG is crushed. Apparently, the new education is telling us it doesn't directly affect SHBG. It doesn't directly inhibit SHBG production. So, but we'll use insulin because it is a good biomarker. Insulin will crush SHBG. Increased fiber intake. You can get a high fiber cereal or drink Metamucil during the day. Additionally, you can add psyllium husk to your protein drink. Fiber probably allows SHBG to build up, probably because it attenuates the glucose. So that's probably why it works, because if you attenuate the glucose spikes, then you also attenuate the insulin response. SHBG increases in a fasting state physiology, so you could experiment with intermittent fasting. Vitamin A, D, and K increases SHBG. You can simply take a multivitamin that incorporates these vitamins. Exercise is important. Olive oil can increase SHBG. Take a teaspoon or two of olive oil per day. Also good for your HDL.
What magnitude of increase are we talking about? Do people need to be wary that they don't overdo it? Or is this
No, because most of this doesn't work much. I'll get to the things that work the best. Testosterone supplement is having promise for increasing SHBG. However, it does bind the estrogen receptor, so be aware of possible related side effects.
I want to explain that real quick to people who don't know what testosterone is, because
we're
probably familiar with it because we saw it a lot in the 90s on bodybuilding.com and all these supplement websites where it was supposed to act as an anabolic agent that was not a steroid. And so it's like, or to have low side effects and stuff. I haven't seen that word in probably 15 years. It's wild. Like, so you would actually see an application for that to be used?
Yeah.
Wow.
Yeah. It has shown that it does increase. And I was looking at tamoxifen too, because there has been studies that showed tamoxifen actually increased SHBG.
Oh, wow.
I don't like SERMs because I don't like blocking estrogen. We know how important estrogen is, and I don't like selective estrogen receptor modulators.
Especially clomiphene. That shit is fucked up.
Yeah, I just don't like it. Estrogen is really important. We shouldn't be blocking it. We can actually put a link in below with Vigor Steve's video on this topic as well. He does a good job of going over a lot of these things I talked about. So it's a lot of the same, but good information. What I'm going to get into here is, what do I see? Especially, me specifically, not to toot my own horn, but I have seen probably more empirical and anecdotal data than just about anybody else in the country. So what have I seen? So Steve talks about his anecdotal experience of raising SHBG to favorable levels. They experience increased anabolism, increased libido, increased sense of well-being. This is exactly what I've seen. Yeah, I've just seen it a lot. I've seen people, it turns out their SHBG is crushed. A lot of times earlier in my career, I guess, doing this, like, we didn't understand this, just like nobody did. So it really, we didn't pay too much attention to it. But, as time went on, you slowly start saying, hey, this is something. So let me tell you like a little anecdotal story. Back in the late 90s, early 2000s, mid 2000s to 2010-ish and a little longer, thyroid hormone was huge in the bodybuilding industry. Like thyroid T3 especially would sell a lot, and a lot of people bought it. And then there was even some articles written about how T3 is changing the face of bodybuilding, and it's allowed people to get bigger, leaner, and all this. The explanation was that thyroid increases protein synthesis, and therefore it's allowing for this anabolism to make your muscles bigger, which is true. It does increase your metabolism. It does There's evidence that it increases protein synthesis, but I don't think this is the mechanism that it allows because it's not anabolic. Despite, you can look it up and it says, oh yeah, thyroid hormone can be anabolic because it increases protein synthesis. In no other case is thyroid hormone anabolic. Like if you give just thyroid to somebody, even if somebody with Hashimoto's takes a lot of thyroid hormone to increase their levels, they're not seeing anabolism from it.
Can you give some examples of dosages they were using? Was it like 100 micrograms a day?
Yeah, bodybuilders use large doses, like 100 micrograms. That's a large.
So 100
dose.
is considered a lot?
Yeah. Of T3, yeah. Not really? T4, but T3. They would use 100 to 200 micrograms. It's a lot.
Okay. I don't feel a whole lot from like 50. And I don't see like rapid weight loss or anything. So I was just wondering how high they have to get to where they're getting all these side effects I hear about with like sweating and they're hot, they're losing weight like crazy. I don't know how much you would need to make that happen. It sounds like you're saying.
Like again, it would be different for everybody, but so, and that's what I'm saying. Like, I mean, thyroid hormone, it's not anabolic, but bodybuilders who were taking it were definitively able to get bigger muscles, leaner, and more striations and everything. My theory is that it was because they increased their SHBG with these high doses. And the SHBG, because they were on big steroid cycles, they were crushing their SHBG. Now, when we give you T3, their SHBG goes up, which allows for more anabolism, as we've seen throughout this whole presentation. And this is the reason why all the guys on T3 were actually getting bigger and leaner, because of the SHBG increase. I don't know that for a fact. It just makes
Does dianabol affect SHBG levels quite a bit? That was really popular back then, right?
Yeah. I mean, it's a very anabolic, but it does convert to a lot of estrogen. So the estrogen might help increase SHBG, but at the same time, like enough testosterone will crush SHBG, even though it converts to estradiol. So androgens have a large effect on lowering SHBG.
But you got to get pretty high testosterone levels, because you and me talked once about this guy on YouTube that was not even involved in hormones, but he was like, I'm in my 30s. I've never had a beard. I went and got my levels tested. My testosterone is like 1,500, but my SHBG is like 100. You remember that guy?
Yeah, I do. Yeah.
Yeah. So like, talk about that guy for a second. Like,
that's a crazy example. I mean, so that does show you that the free hormone is important. It's just not the most important metric. So yeah, if you have 1,500 testosterone and 100 SHBG, you just don't have enough free hormone to actually have to diffuse through the cell, bind to the androgen receptor, and have this cascade of effects.
Do you think it's like letting go and immediately getting grabbed again? Is that what's going on?
Yeah, if all of your testosterone is bound up by the SHBG, because if there's a lot of SHBG, it has a high affinity. It will bind all that testosterone, and then there's none of it to diffuse into the cell and actually have the cascade of effects. I mean, we looked at other mechanisms where testosterone bound SHBG can be utilized, but it is evident that some free testosterone is needed. So that's why I'm not saying that free testosterone isn't important. It's just not the most important metric. And the measurements that we have are very inaccurate, or notoriously very inaccurate.
All that matters is the extreme cases, because these guys are acting like you can use it as a calculator in the middle zone, like 30 SHBG to this much total T, you don't need treatment. But it seems to me like if the SHBG is too low or too high, you have a problem, but you don't like nickel and dime people in the center with like 20 to 30 range SHBG multiplied by their total to use it against them to deny them treatment.
Yeah.
You know what I mean?
That's right.
Because there's some of them saying they won't even order a test for total T. They only order the free T.
Yeah.
And it's like, I don't think that's good.
No, it's not good at all. I mean, for multiple reasons. A, we know that free testosterone is not the most important metric. And B, the free testosterone tests, no matter how you get it, is notoriously inaccurate.
Excellent presentation, guys. I feel people out there learned a lot tonight. I know that I did. Great job, Jay and Ryan. Thank you for doing this tonight. You have a great night. Take care.